Good afternoon, everybody. I'm Captain Liz Kretovic. I'm the Deputy Hydrographer in the Office of Coast Survey, and I'm also the Program Manager for NOAA's Precision Navigation Program. And today we have Charles Goodhue and Zach Finn from ERG. They are going to be speaking about a socioeconomic study that they conducted for us over the last year. It has a lot to do with the benefits associated with precision navigation, and also is a tool that we can use to help us to identify future ports that may see a lot of benefit from our program. Our program is basically the NOAA Nav Services Program offices, so that's the Office of Coast Survey, the Office of Co-ops, IUSE, NGS, and also Weather Service. And so we're working together to create a way that we will integrate NOAA's data that's important to a mariner and then disseminate it so that it can be used by navigation, marine nautical chart viewers, ECDIS, portable pilot units, and that kind of thing. So without further ado, I'm going to turn it over to ERG so that they can get started. Thank you.
Thank you, Liz. This is Charles Goodhue with ERG. There we go. So who we are, Zach's in the front row. I'm Charles Goodhue, and we are from ERG out of Lexington, Massachusetts. We do a lot of work for the government. This project was mostly economics and some social science. And I think this might have been like our 85th project for NOAA over the last 10 years. So Liz just provided a little bit of an overview about precision navigation. We'll be talking about some of the benefits and briefly the successful pilot study in the Port of Long Beach, where precision navigation helped increase the draft from about 64 feet to 68 feet. And we'll be diving into that in a little bit more detail over the coming slides. So we had a few study objectives for this. The first that we dove into was prioritizing U.S. seaports based on quantitative data. And this was to show which ones we expect to benefit the most from precision navigation. And I'll be talking about that toward the end of the presentation. The other two are very intertwined: developing valuation methods and then implementing those valuation methods at the Port of New York, New Jersey, and the ports of the lower Mississippi. And we were looking at several benefits that precision navigation would have to those ports and the various stakeholders at those ports. So we did a lot of talking, had a lot of conversations as part of this project. So I just had a couple quotes to share that I think do a nice job of capturing some of the benefits of precision navigation before I'll list some more off on the next slide. One of the biggest issues facing pilots is accurate determination of underkeel clearance. Maximizing vessel draft has a very significant impact on commerce. As I noted, the Port of Long Beach, where precision navigation is being implemented for oil tankers, they were able to increase their draft from 64 feet to 68 feet with very large benefits there in terms of reduced operating costs and bringing more goods to port at a sort of cheaper cost. Having all weather information in one central location would have a huge benefit to pilots. When a weather event is imminent, such as fog, having access to all the available information has a huge impact on decisions and efficiency. So just capturing some of these benefits of precision navigation: saving time, reducing delays. You may know you might be at port loading up, and you may get some information that says, okay, maybe I don't load quite as high. Maybe we try to get out of there a little bit sooner. So again, maybe you're on your way in and you want to speed things up because you know of something incoming, or maybe you slow it down and save some fuel because of the information you have. Minimizing incident risks, so the safety component of this. Precision navigation provides a lot of information about tides, under keel clearance, the current. So again, major benefit we looked into the study on minimizing the risk and the associated safety benefit. Allowing pilots to more confidently navigate. Again, just bringing up the Port of Long Beach as an example here, navigating with a little bit less under keel clearance and doing so just as efficiently. And ultimately, as ships get larger, this is going to help the ports bring those ships in with that confidence and also maintain competitiveness of an individual port that may implement precision navigation. I'm going to turn this over to Zach Finn, my colleague from ERG. Here you go, Zach.
Thank you, Charles. So I'm going to talk a bit today about the case studies that were conducted as part of this project. And a big part of the case studies was taking the benefits that Charles had just talked about for precision navigation and trying to bridge the gap between those benefits and how we actually looked at the value that precision navigation was going to bring if it were implemented at a specific region or port. And so the first step in doing these case studies was to gather a lot of data from major US ports that we could use to analyze things that correlated to the benefits that we found for precision navigation. So a lot of the data sets that we looked at were from major sites such as the US Census, the US Coast Guard, as well as the Waterborne Commerce Statistics Center. And we tried to focus on data points that were correlated with some of those benefits. Just for example, from the Waterborne Commerce Statistics Center, we're able to look at how many vessel calls occurred at a specific port in a given year. And more specifically, we were able to determine for each level of draft how many vessel calls occurred. So at 34 feet, how many vessels were coming in at a specific port, 35, 36, so on and so forth. And so data like this was used to help analyze the specific benefit that precision navigation would bring to the port. So in addition to this data that we were able to gather from these data sources, we were also able to talk to various stakeholder groups at the specific ports and regions we were looking into, the lower Mississippi, as well as the Port of New York, New Jersey. And from these conversations, we were able to gain additional insight into how the pilots there viewed precision navigation and the potential impact it could have on their port and their navigation, as well as gain additional specific data for that port to help us in our analysis. So after we had gathered all of this data, we determined that it would be best to try to come up with a methodology for how to take that data and then evaluate the benefits to precision navigation at the specific port. And we focused on two benefits for the case studies that we were able to provide quantitative estimates for. The first was reduced operating costs, and this relates to the benefit of precision navigation being able to help pilots and vessels operate more confidently with less under keel clearance. And so if they're able to do this, then they'll be able to either increase the amount of cargo that they're able to take during a transit, and over time, hopefully be able to increase the size of the vessels that are able to enter and exit the port as well. And now translating that into something that we were able to estimate from our data was being able to look at how that would decrease the cost it takes to ship 1 unit of cargo. And so that was what we used to make our quantitative estimate. Now, the second benefit that we looked into was reduced incidents, and specifically we looked at reduced elisions, collisions, and groundings. And so the benefit from precision navigation that relates to that was that vessels will be able to minimize their incident risk. So using all of the integrated data that NOAA will be able to provide, if vessels and pilots are able to better understand conditions, they'll be able to navigate more safely and thus hopefully avoid some of the elisions, collisions, and groundings that are occurring at the ports. And so if elisions, collisions, and groundings are decreasing, then based on the estimates that we have for the economic impact of an elision, collision, or grounding at a specific port, we're able to then provide a quantitative estimate for how precision navigation would impact at a specific port. And so before I go into an in-depth analysis of one of the case studies, I just wanted to provide a brief overview of some of the results from our case studies for these two specific estimates. So for reduced operating costs in New York, New Jersey, we found that precision navigation would account for a portion of a $216 to $472 million benefit, and that is an annual savings. And for the ports of the lower Mississippi River, the estimate was 200 to 440 million. And I will explain in just a few moments what I mean by a portion of that range. And for the reduced incident estimate for New York, New Jersey, the estimate was 1.2 to 3.3 million dollars, and that was an annual saving. And for the lower Mississippi River, the estimate was 3.7 to 9.8 million dollars. Now, the other benefit that we looked into but didn't provide a quantitative estimate for was the reduced weather-related delays that precision navigation would be able to help with. So specifically for the ports of the lower Mississippi, I'm just going to walk through a little bit of what was going into those quantitative estimates, kind of some of the context and assumptions that were made as we developed these benefit ranges. And so I mentioned the benefit range for reduced operating costs was between 200 and 440 million, and that's in US dollars 2017. And that's the estimated annual savings, assuming that vessels are able to utilize an extra foot of draft. And so this range isn't directly estimating precision navigation's impact. It's looking at if vessels are able to utilize an extra foot of draft, how will that decrease the cost it takes to ship a unit of cargo. And so where precision navigation comes in is if precision navigation is able to help pilots operate with less underkeel clearance and utilize more draft, then they'll be able to get at a portion of this benefit. Now, how much precision navigation will be able to get at this range will depend on a few factors, and that includes how many vessels precision navigation will be able to impact in terms of the utilization of an extra foot of draft. Will precision navigation be able to impact most of the vessels that are traveling, the ones that are deep draft vessels as well as the smaller vessels as well? Or will precision navigation only be able to help a portion of the vessels, specifically the deep draft vessels? And so depending on what precision navigation is able to do once it's implemented in the ports of the lower Mississippi will determine where in that range the benefit lies. And another factor that goes into this as well is that we are assuming that ships are able to load more cargo onto their ships. Or over time at the ports of lower Mississippi, as ships get larger, the largest ship that's able to traverse the ports along the river will be able to increase. And so if those things happen, then it will be more likely that precision navigation will help get at this benefit as well. So the next benefit that we looked at was reduced incidents. And again, this was specifically looking at reduced elisions, collisions, and groundings. And so the estimate was 3.7 to 9.8 million dollars annual savings. This estimate is specifically for looking at what happens if an elision, collision, and grounding occurs, and looking at the loss to human life or person injuries, vessel damage, as well as a vessel loss, the loss of cargo, as well as any cargo damage. In addition to that, any economic damage, including things such as oil spills. So that's what's encompassed by this estimate. What this estimate does not look into is kind of the overarching effects of if one of these incidents shuts down even a small portion of the lower Mississippi River. Because of the expansive nature of the lower Mississippi, the number of ports and the amount of commerce that occurs up and down the river, if even a small portion is shut down for even as short a period as a day, the economic impact of that along the entire supply chain could be in closer to the billions of dollars. And so it was important to acknowledge that as well when looking at the impact precision navigation could have at the ports of the lower Mississippi. And very specifically, we took a very serious look at the reduced incidence benefit specifically for the lower Mississippi because after many discussions with the pilots associations and pilots at the lower Mississippi, it became very clear that this was a big concern for them in terms of the safety in navigation at the port and the many ports that are along the lower Mississippi. They face unique challenges in navigating along the river that include fog blackouts, accumulation of sediment along the riverbed, as well as flooding. And not only do they have to deal with these issues, but they happen at a very high frequency. And so if precision navigation is able to help pilots better navigate and better accommodate these conditions, then there's a serious economic benefit that could be achieved through helping them deal with these conditions. Now, the last thing that we looked at but didn't provide a quantitative estimate for was reduced weather-related delays. Part of the delays that we looked at were already accounted for in the safety estimate that we had for reduced incidents. But there were other things that we had to consider that weren't included, and those include allowing pilots to better plan and react to adverse weather events. So if precision navigation allows pilots to, at the onset of their travels, better anticipate events such as strong currents or fog or things like that, then they'll be able to better plan and time their trips, and that will avoid unnecessary delays that cost a lot of money as well. And the second aspect of delays are tide restrictions that may occur along the lower Mississippi. And the reason that this is a big concern is if the variance in tides also comes with a variance in the amount of draft vessels are able to use when coming in and out of a port. And so at specific times, the tide restrictions may cause delays in a certain vessel leaving or entering a port. That if precision navigation were able to help pilots utilize more draft, then the variance in tides might not affect them as much. And so some of the tide restrictions that are seen along the lower Mississippi may be able to be lifted. And so the delays that are associated with the tide restrictions may be able to be decreased. And so I just wanted to briefly mention the case study that we did, the Port of New York, New Jersey, which followed along very similar lines to what we did for the ports of the lower Mississippi. And we looked at reduced operating costs, reduced incidents, and reduced weather-related delays as well. We came up with slightly different estimates, and that is because we used port-specific data. We looked at how many incidents were occurring at the specific port, as well as the unique challenges that pilots are facing at the Port of New York, New Jersey, and that included dealing with wind, fog, currents, and difficulty operating under bridges, including the Verrazano Bridge. And so as different ports are affected by precision navigation differently, it's important to look at kind of what areas might be able to be most affected by precision navigation and where precision navigation might be able to have the most effect moving forward. And so with that, I'd like to pass it back to my colleague, Charles, who's going to talk about the port prioritization that we did for this project as well.
Great, thank you, Zach. So jump into the results to start, and then I'll walk through the process. We did some work to look at quantitative data sets. So we did not, with the exception of the ports of the lower Mississippi and the Port of New York, New Jersey, do any sort of economic valuation. What we did here as part of our process was look at the types of data sets, many that Zach has brought up in terms of waterborne commerce statistics, census data with the dollar values of the commodities going into the ports, the numbers of collisions, and groundings. And we tied those to indicators that precision navigation could help. And I'll go through some of those in a little more detail, but an example here might be a port with a lot of incidents has a larger potential to reduce those incidents and claim a larger benefit. And again, I put the top 5 ports as prioritized by our methods in terms of those that will likely benefit the most from precision navigation. The ports of the lower Mississippi being the first. I also put one of their major commodities that go through, so soybeans there. Ports of Houston, Galveston, Texas, as well as the port of Beaumont, Texas, both with crude oil. Port of New York, New Jersey at number 4, and then the port of Savannah, Georgia at number 5. I'll walk through a little bit about the methods for us to get there. So we developed index scores. And what we did, the reason we did this was to, across our different metrics, have some sort of comparability when we look at dollars, number of incidents, number of vessel calls close to the maximum draft, those that are very closer to the bottom and maybe don't have that room to increase their tonnage. So an example here of how we developed an index score. The top port for tonnage, being one statistic we used, was Houston, Texas, with 173 million short tons. The next biggest port here actually was South Louisiana, with 135 million short tons. This is all annual data. And then how we did this is the largest port within that metric would get the score of 100. So that's your sort of top metric. And then all other ports were given a index score relative to that top one. So for example, for tonnage, South Louisiana would then get a 0.78 or 78 relative to that 100. So that there's, again, now we have a 78 for South Louisiana for tonnage, but then we could come up with very parallel metrics across, or sorry, very parallel index scores across the other metrics. So once we developed those index scores for each of the metrics, we developed a composite score. So some of the metrics we used as an indicator for the effectiveness of precision navigation: number of vessel calls, Waterborne Commerce Statistics Center's tonnage score, so how much tonnage you're bringing into the report, number of vessels within 1 foot of max draft, and number of vessels within 5 feet of max draft. And this is important because those are the ships going into port that probably are going to take most advantage of the benefits of precision navigation. So if you are 20 feet away from the maximum draft, you're less likely to take advantage of that extra foot of underkill clearance because you're not operating at that decision point. Whereas if you are operating very close to the maximum draft, that is the type of situation where, well, if I had an extra foot, maybe I can take advantage of it. Or maybe with precision navigation, I bring the same amount of cargo in, but now I'm not as impacted on delays from tide restrictions. So, I think those are the ones that are going to benefit the most, and that's why we included both of those as metrics. And then we have U.S. Census Bureau, the value score, so that's the dollar value of the cargo going in, and of course, the more going in, the more potential to benefit. And then incidents within 3 kilometers, we gave a score. Here, as I said before, the more accidents you have, the more potential to reduce those accidents and claim that benefit. So again, those are some of the indicators we used, and we developed 3 different weighting schemes to look at the sensitivity across those different metrics. So here, this shows the ranking of, these are essentially our top 7 ports by the different types of composite weightings. So one thing we looked at, if we put an equal weight on all 6 metrics, what does that ranking look like? If we rank more towards weight and tonnage and dollar value, so those high volume ports, high dollar value ports, what does that ranking look like? And then we looked at the rank for more weight to incidents and calls near the maximum draft. And those 2 we wanted to specifically call out because those very much align with our valuation methodology where we looked at specifically the benefit from an extra foot of under keel clearance or taking advantage of that extra foot of under keel clearance, as well as the number of safety incidents. So what does that look like? And ultimately, between these 7 ports, the lower Mississippi River, ports of the lower Mississippi River, Houston, Galveston, Texas, Beaumont, Texas, the Port of New York, New Jersey, Savannah, Georgia, Los Angeles, California, and the ports of the Columbia River, we have the top 5 rankings in each of these 3 weighting systems. So we did see, even as we moved to different types of weighting systems, that the same groups are really rising to the top. And that was just a way, again, to test the sensitivity. Is we're not exactly sure maybe what weight's precisely right. So again, that was one way for us to take a look at there. So challenges. I don't think this is a problem that is only with economists. A lot of areas, the more data you have, the more you can do with it. It was great that we had the Port of Long Beach pilot study, because we got to see that example of how under keel clearance can increase in that specific case by 4 feet and have huge benefits. So, the challenge here is that is sort of the limit of where precision navigation has been implemented to date. So we tried to come up with our defensible estimates using pretty wide ranges and using terminology like a portion of, because again, it really is going to take an implementation to understand what that portion is. It's a very large number, and we think it's a very large number. We're pretty confident it's a very large number, but sometimes you get in trouble with using a very large number and using very strong language about that. So with that challenge in mind, I think going forward, you take it a few more years as precision navigation starts to get implemented at ports. We start to get data on safety reductions. We start to see if pilots are utilizing that extra foot of draft or that extra 2 or 3 feet of draft at certain types of ports. We start to see that pilots are timing things better or making behavior change decisions. That's when we can really start narrowing those results. And then also, as Zach pointed out, we looked at some results qualitatively as well, putting dollar values on those once that behavior change is understood. And I think the pilots we talked to and some of the ports we talked to did a really good job providing us a good sense of how that value is created. For them, it was really hard to pinpoint just how much value could be created. So again, these recommendations, what's the data look like on reducing incidents? What is that behavior change regarding operations and how you operate? And then what's that behavior change and how does it play out in terms of minimizing vessel delays and weather-related events? Those are some of the things that could be looked at a few years from now, potentially, as there's more implementation of precision navigation across more ports. So with that, we want to thank you everybody here, thank you everybody on the webinar, and we wanted to open it up to questions for the second half of the presentation. Yes, and we're going to pass the mic so people can hear the questions, and then we'll pass it back for the questions.
Hi, thanks for the presentation. Wondered if you had any, I guess it would probably be pretty much in the port outreach, an estimate of investment required for the specific concerns, like fog sediment flooding in Mississippi and the wind, fog currents, draft, the bridge.
So the cost,
yeah, just the investment required.
The cost side. So Zach, please feel free to add to what we've talked. So we talked with the folks at ProTides who helped develop the sort of PPU component and part of the system at Port of Long Beach. There's also a number of sensors that you need. Our sense is that it's going to vary port to port based on your needs and the specific characteristics of the port you're going to need to address. But I think ProTide said that's going to be somewhere around $50,000 annually for sort of that PPU component. There's also going to be sensors that range from what we've heard. It might be $30,000 to $100,000 each. I'd say somewhere we're talking several 100,000 a year, probably less than 500,000. 250,000 might be a reasonable estimate, but again, that's going to vary much depending on the size of the port, how large it is. And again, it's very custom to a port. Zach, did you want to add anything on that?
Yeah, and I also say I think that once you get it up and running, the cost to continue to do it for years and years will probably decrease somewhat. There'll be a little bit more of a cost to implement it at first. And I would also say that we talked to a lot of the stakeholders at the Port of Long Beach, and they talked about a lot of what it would take to really get the program up and running in other places. And they were speaking from experience in terms of the groups that it took to really implement the system that they see at Long Beach. And they said that just the amount of effort and the amount of cooperation from all of the stakeholders involved would be really necessary in terms of making a really successful program. And I think that the more stakeholder engagement that you were able to get, then that would kind of ease the costs and ease the ability that you would see to implement the program.
Great. Other questions here? In the back.
During your study, did you determine which data set would be most beneficial to a given port? Have you gone down to that level?
So I'll start. All the data sets we used were more or less national data sets with specific data for every port. So Census has, I think it was the top 200 ports have the dollar values of tonnage going in. Waterborne Commerce Statistics Center has the number of ships, the number of vessel calls by their draft. So you can see which ones are, maybe if the draft allowance is 50, you can see that there's 60 calls coming in per year at 50 feet. Maybe there's 300 calls coming in at 49 feet. So you can see that distribution of how large the ships are coming in. So again, that's available for every port. The Coast Guard has data on incidents, and that's based on latitude, longitude. So what we did for that data set was map out the elisions, collisions, and groundings compared to the waterways. And again, that's available for every port. So the data sets we used were all publicly available data sets and available for every port we analyzed there. Anything?
Thank you. I'm just going to focus on some of the statistics you provided for the lower Mississippi. It's pretty wide down there. There could be some tidal influences. You're talking about impacts to precision navigation associated with flooding. Is that associated with the amount of fresh water coming south down towards the ports of New Orleans? Or was this potentially impacting the port itself? Was this because of not being able to get under some of the bridges there? I'm curious about how the flooding aspect impacted precision navigation. And then you also only identified fog as a reduction to visibility issue, but there are also other things that can occur meteorologically that could reduce visibility. Did you look at any kind of data associated with heavy rain, hurricanes, and things like that?
Do you want to start with this one, or? Okay. So we did have a lot of conversations with the pilots of the different sections of the lower Mississippi, and in terms of the data, I'd say it was somewhat like we understand how much flooding there was, for example, or we understood.
To what basis? What are you identifying as flooding in the lower Mississippi?
Well, so are you referring to a slide we had flooding? Maybe we can slide back to it.
We talked about flooding on a couple of slides, one in particular associated with the lower Mississippi.
Okay.
Are you talking about the river level because of increased freshwater outflow? Are you talking about potential damage to the ports because of the water level? Are you talking about the currents?
So in these estimates, we are not talking about damage to the ports from flooding. This is specific to, I'd say, more ship operation, ships going from the sea buoy into port, and our benefits that we're talking about in reduced operating costs, this quantitative benefit, or are you referring more to the qualitative benefits?
Yeah, I'm trying to figure out how you're applying flooding in this particular situation, and how that affects the ship navigation in that rather large channel. So I'm sorry if you didn't get into that kind of detail.
No, I don't think we really explored too much the flooding side of things. Maybe I'm misinterpreting the question to some degree. I apologize.
I'm one of the weather guys in the audience.
Okay.
Sorry about
just so
that.
everybody can hear you well.
Yeah, weather, sorry.
No, I understand.
And we issue the forecast for water level, okay? And we also have current information, right? So we have a nexus between weather service and ocean service here, right? And so I'm just trying to get an understanding on how, when you articulate flooding impacts ship operations, I'm not sure how I actually can apply that to the actual forecast. Current, water level, damaged infrastructure, I don't know where you're coming from. I mean, there were over 200 days where the lower Mississippi was in flood stage during the last calendar year. And I don't know whether or not that impacted shipping a great deal, right? So
that makes, okay, understood. So here what I would say is what we would be looking at in terms of maybe what precision navigation could do is if ships have that understanding of flooding, currents, etc., resulting from weather, we are looking at how can ships, if at all, use that information to reduce their operating costs. So for example, maybe they know that there's an event coming up and they can time something better because of that event. And there's some sort of benefit there because they use less fuel getting there faster, or they load their ship at the port accordingly because they know of some sort of restriction that's going to be in place as a result. So we're talking about how ships are reacting to weather, flooding, currents, tides, the distance between the bottom of their boat. We're not necessarily looking at the flooding impact on any infrastructure here. So it's really, what is the behavior change of the ships that precision navigation can relay to them based on some of the maybe weather data or some of the tide data. Does that make more sense? I'm sorry for. Okay.
Awesome. So our first question is, when looking at incidents, were you able to get a feel for what incidents would have been mitigated by precision navigation, i.e. engine failure would not be mitigated? So what would be?
So specifically, we looked at elisions, so hitting something else, collisions, two ships hitting, and groundings, the basically body of your boat hitting the floor of the river or ocean. So, what I would say to this question too is that, we're looking at this rather broadly, and to look incident by incident would really be getting maybe into the weeds for trying to come up with an estimate. So we did not look at every incident specifically, but we did narrow the U.S. Coast Guard data down to elisions, collisions, groundings, and for ships that would most likely use precision navigation, like tankers, barges, cargo ships.
Okay, you may have answered this one already, but it sounds similar to a previous question. How do these estimates of economic benefit compare to the cost to implement precision navigation? It wouldn't be cheap to bring together all of the information a navigator would need. So you kind of answered that, but maybe elaborate.
Yep. Yeah, very similar to the first question. We think the costs would be in the several hundred thousands annually, something around that. That could really give or take a lot depending on the size of the port. I don't want to say it's 250,000. We've talked to folks. This is not including maybe the government investment. This might be more on the technology, the sensors, the PPUs, things like that. So I want to stay away from everything we've said has nothing to do on the NOAA side. This is very much more of the decision that the ports themselves would be purchasing based on, you know, the sensor needs, the portable unit needs, etc. We do think the benefits are much larger, you know, several times larger, maybe more than that, but we wouldn't know to what degree until we did see more implementation. But we're pretty, I'd say I'm very confident that they're much higher, but based on what we've seen.
And there is one last question. I believe it was mentioned in one of the slides. Did you look at air draft?
So I think air draft is sort of a component of what precision navigation can take care of. So I think the Verrazano Bridge was an example. Zach brought up as one of the main considerations, or a major consideration at the Port of New York, New Jersey. Having that type of information in a broad sense is something we looked at. We didn't necessarily, again, look at the granularity of this one bridge, this one height, this one piece of efficiency here. Zach, do you have anything you want to add to that one?
Yeah, I would say kind of in tangent to that, something else that we considered in terms of the big impact that it could have, both on reducing incidents as well as just the downstream impact on the supply chain of something really horrible to go wrong with a major incident, is that it is somewhat dangerous to navigate under these bridges under certain circumstances. And so even if it doesn't happen very, very infrequently or even very rarely, if precision navigation and the data that pilots have can at all reduce the risk of an collision involving a bridge, then that would have a big impact as well.
Late entry question. From Melanie, please forgive me if I missed it. This is a socioeconomic study and census data was mentioned, but what about considering ecosystem services data, something else that ties the navigation of an area of interest to commerce?
Yep. So yeah, that is not something we looked at as part of our scope of work. The only thing related is that the incident data did include environmental cleanup, which is loosely related to ecosystem services. So that did include like reduction in fisheries, tourism to those areas. So the number in terms of, I'd say this increased safety was loosely related.
Could you go to the slide that has the top 5 ports, the one with the pictures? I like looking at pictures. Yeah, that one back. Yeah, that one. So when you did this, I know you have something in the value chain, but you know, these ports that you're looking at, you know, a ton of soybeans, the value of that versus Houston, Beaumont, that's oil, versus New York, New Jersey, which is just about everything. They not only oil and agricultural products, but containers. And then Savannah is the only port there that is truly just containers and car carriers, basically. Have you captured what the value of, say, a foot of draft is for all of these type of products into these ports? Like, but the reason why I'm asking, the container ship market is one market that's extremely growing real fast in this industry. They're going to have 25,000 containers on them. They're going to be 50-foot draft real soon. And what does a foot of draft, how many containers is that? Is that 1,000 containers? It could be 1,000 containers of paper or computers or whatever. Did you drill down that far into that area? That's it.
Nope, great question. So there's two things that I want to separate out that sort of come with this question. The first goes to the reduced operating costs of the ships. So here, in a sense, tonnage is tonnage. The weight of a ship, the larger it gets, typically we see a reduced operating cost per ton of goods. That's why, you know, a lot of times we want larger ships to be able to get into port because of that cost savings. So that is independent in more or less of the value of the actual good. Whether you have cell phones or soybeans, that benefit to the ship is going to be based on the tonnage itself. So that's one part of it that we looked at when we bring that $220 million to $440 million figure, and that portion of it, we're talking about an operational savings there. The other one's very important in that downstream economic impact. And that gets very nuanced. So bringing in a more dollar value, higher dollar per ton goods, very valuable. Again, electronics versus soybeans. There's going to be an economic impact related based on job creation. You're bringing very expensive goods in and out of the port. That ties to jobs to create that value. So there's going to be more jobs generally with higher dollar value goods. That's something that we did not dive into, that sort of economic impact ripple effect. In depth, we talked about it sort of more conceptually in the socioeconomic report here. The other thing is sort of sensitivity of the cargo itself. Yes, there's dollar values associated. How late can it be varies from agricultural products to cell phones. That's again part of the nuance here. So we looked again on the operation cost side, yes, in terms of the tonnage, but we did not really dive into the dollar value and the economic ripple effect of the different values of different goods at each port, if that makes sense. Does that answer the question?
Sorry if I missed this. What was the period of time of the data sets that you looked at? Just 1 year?
Primarily 2017. For the baseline data for the incidents, we used 2001 to 2013. All right. Just because we wanted a larger baseline and some ports did not have a lot of incidents. Yep.
So you had a 3-column table that I think ranked the relative benefits, and the first 2 methodologies seem to rank the ports fairly similarly. And I just noticed LA Long Beach went to 15 on the 3rd category, which is related to incidents and the relative benefit or closeness to the maximum draft to the under keel clearance. So I just wonder if you could suss that out a little bit, why LA went to 15th there.
So I can start, and then I think Zach, I think one factor with the West Coast is you're talking about larger swells. So I think there may be sometimes fewer coming in closer to the max draft, which might have hurt LA in this particular set of rankings, even though because of some of the larger swells, it's still very important. So again, we use methodologies that could cut across hundreds of ports to try to get here. So it's not necessarily pinpointing everything. Zach, did you have, it sounded like you have.
Yeah, I think the other thing was that the more weight that we gave to incidents also hurt LA Long Beach here, because as a baseline, they did not have many incidents. And so the room for improvement on that was not very high because they're already doing a good job in determining safety. And so I think a combination of those things kind of went into the ranking that it had for that specific weighting system. But I think that's also why we didn't just look at one weighting system. We tried to look at a bunch of different things in case there was one that was weighted unfairly to one port or another, because as Charles said, they had to cut across so many ports. And so by if you just looked at that weighting system, you would think that precision navigation might not have a large impact. But by looking at the others, you can see that that there is room for precision navigation to have an impact there.
I'm wondering if, since your data sets probably reflect current traffic patterns into ports, right? If that introduces in some sense a bias, and especially since you have unequal weighting among your parameters, if you added a variance component and propagated that variance to the variance in the economic and see which ones were more sensitive to variations in traffic, because you mentioned competition as a motivation, right? And if your study discloses that, I don't know if Los Angeles competes with Seattle, but say San Francisco, right? And traffic patterns start to change, then you may want to be able to inform the impact of traffic changes on the economic benefit. I think it would add a valuable dimension.
I would say I agree 100%. I think sort of given the scope and resources of the project, it's not something we necessarily did. We didn't do a whole lot of forward-looking modeling. I think this was to really help maybe NOAA hone in on some next steps here. But I agree. I agree with all those points. I think those would be great next steps.
Something that I would add to that is that as part of the project, we created an Excel tool where we kind of went through the steps and the inputs in our methodology, and you can see specifically for each specific variable what the values are. And we made it in such a way that NOAA would hopefully be able to use it in the future if they want to change the variables. So if they wanted to account for new traffic patterns in 10 years, they could update the model to see how that would change. So that's something that would be a possibility as well.
I think that's it. So thank you all for coming, and let's give these guys a round of applause.